Okay, so today we're going to talk about operations with polynomials. So if you take a look at example 1, all they're asking us to do is find the sum of a polynomial with 4 terms and a polynomial with 3 terms, which we call a trinomial. Okay, so all we really have to do is just combine our like terms. So you're looking for similar exponents. So here we have a positive x cubed, and over here we have a negative x cubed. Well, a positive and negative of the same thing are really just going to cancel off with each other. All right, so now we look at here, we have a 2x squared. Now, as you look your way across, there's no other x squared term, so since there's nothing to combine it with, let's just bring down the 2x squared. All right, now here we have a negative 3x, and as you look across, here we have a negative x. So if we combine negative 3x and negative x, that'll give us negative 4x. And then finally, we can just combine our numbers. We can combine this negative 1 with the positive 4 to give us positive 3. Now with number 2, we're subtracting a trinomial from another trinomial. So the first thing we're going to have to do is we're going to have to take this negative sign right here, this minus sign, and we're going to have to distribute it to each term within the second set of parentheses. So I'll just bring everything down in the first set of parentheses. And in the second set, when you distribute a negative, the signs change. So negative x squared, and then a negative times positive 2x would be negative 2x. And then negative times negative 5 would be positive 5. And now we could just combine our like terms. So I can combine my 5x squared with my negative x squared. So 5x squared minus x squared would be 4x squared. Then I can combine my negative 3x with my negative 2x to give me negative 5x. Okay, you just add the numbers in front and keep the variable. And then we can combine the negative 7 with the positive 5 to give us negative 2. Okay, so in number 1 we did addition, number 2 we did subtraction. Here in number 3 we're going to multiply. We're going to multiply a binomial, bi means 2, so 2 terms, by another binomial. 2 terms times 2 terms. All right, so all you have to do is just double distribute. So I'm first going to take the x and distribute it to both terms in the second set of parentheses. So x times x squared would be x cubed. All you're really doing is adding the exponents. There's really a little 1 here. So when you add 1 plus 2, it gives you the 3. All right, and then x times negative 7 would be negative 7x. And now we're going to distribute the 9 to both terms in the second set of parentheses. So 9 times x squared would be positive 9x squared. And then 9 times negative 7 is negative 63. Okay, so now what you want to do is, in order to write this in standard form, we just want to rearrange this so our exponents go in descending order. So we're going to write our x cubed first, then our 9x squared, then our negative 7x, and then our number at the end. Okay, number 4 and number 5, we're going to skip. You guys are going to do that tomorrow in class. But let's jump down to number 6. Now, number 6, we're actually multiplying 4 separate terms. So we're taking the product of 4 individual terms. So you're really just going to pick 2 of them. I usually just go right in order. So let's multiply this first. This is called a monomial because it's 1 term. And this is called a binomial because it's 2 terms. So let's just first multiply n times n plus 1. So what you're going to do is just distribute the n to both terms. So n times n is n squared, and then n times 1 is just 1n, which I just like to write as n. All right, so now once you multiply those, let's bring everything else down. Okay, now what we're going to do is we're going to multiply the n squared plus n by the n plus 2. So we're not worrying about this last term, this last binomial right now. Okay, so we're going to have to double distribute. So we're first going to distribute the n squared to both terms. So n squared times n, again, you add the exponents, so it gives you n cubed. And then n squared times 2 is positive 2n squared. And then distribute the n to both terms. So n times n is positive n squared. And then n times 2 is positive 2n. Okay, so I'm just going to put that in a big parenthesis, and I'm going to bring down my n plus 3. Now before I multiply together this first parenthesis by the second parenthesis, you can combine like terms here. See how we have a 2n squared and a 1n squared? Well, 2n squared plus 1n squared gives you 3n squared. So I'm going to combine these to give me 3n squared. And I'm just going to bring down everything else in that parenthesis. So we have n cubed, and then plus, and then let's bring down the plus 2n, and let's bring down that next parenthesis of n plus 3. Okay, and to finish, all we have to do is multiply together this first parenthesis, which is a trinomial, by the second parenthesis, which is a binomial. Okay, so we're first going to take the n cubed and distribute it to both terms. So n cubed times n, you add the exponents as n to the fourth, and then n cubed times 3 would be plus 3n cubed. Okay, now let's distribute the 3n squared to both terms. So 3n squared times n, well, again, you add the exponents. So this is really 3 times, there's a 1 in front of this n, so 3 times 1 is 3, and n squared times n would be n cubed. So it's going to be 3n cubed. And then 3n squared times 3, just multiply the numbers, so 9n squared. And then finally, let's just distribute the 2n to both terms. So 2n times n is 2n squared, and 2n times 3 is 6n. And from this point, let's combine our like terms, and then we're done. All right, so the end of the fourth, there's no other terms raised to the fourth, so we can't combine that with anything. We can combine the 3n cubed and the 3n cubed to give us 6n cubed. We can combine the 9n squared and the 2n squared to give us 11n squared. And then the 6n doesn't combine with anything, so we could just take that and bring that right down. So there's our answer. Okay, now number 7 wants us to find the first term and the last term if this were written in standard form. So the long way would be to actually do the whole entire problem out, which I'm going to do right now. So what you could see is, I took the x minus 4, and because it was squared, I just wrote it out twice. I double distributed here, combine my like terms. Then I had to distribute the negative to each of these, and then combine my like terms again to finally get the first term to be 2x squared, and the last term to be negative 21. Now that was a lot of work. You actually don't even have to do any of that to come up with the first term and the last term. Okay, so what you can do instead is, I'm going to bring down the x plus 5 and the 3x minus 1, and I'm going to bring down the minus. Now instead of writing x minus 4 squared, let's actually write that out twice. So if I want to find the first term, all I have to do is just multiply together the first two terms in the first product here. So x times 3x would be 3x squared. And then I'm going to subtract from that the product of the first two terms here. So x times x would be x squared. So when you combine those, 3x squared minus x squared is just 2x squared. So the first term would just be equal to 2x squared. Now if we want to find the last term, all we have to do is multiply together the last terms here. So positive 5 times negative 1 is negative 5. And then again, I'm going to take this subtraction sign and I'm going to bring it down. And then I'm going to multiply together the last two terms here. So negative 4 times negative 4 is positive 16. And when you combine those, that will give you the last term. So it gives you negative 21. So that is a lot faster than doing out the entire problem. Although if you want to, do the entire problem, go for it.